One of the last things I want to talk about here with big data is some of the algorithms that we can actually use to work with this sheer amount of information. So one that I want to highlight here is called MapReduce. Now, MapReduce is a very well-known algorithm in the big data realm. Now, it's been, of course, transformed significantly since its original inception to handle even larger amounts of information. But the idea here is that we take a very large amount of information, let's say text, and then we map it to smaller parts, break it out, and then we recombine that to produce a final result. Okay. And so if you can use this as an example, right? If we're trying to, let's say, sort a deck of cards, right? If I give you a whole bunch, or if I give you a full deck of cards that is completely shuffled, but I want you to sort it out in numerical order as well as the suits, it would actually take you a little bit of time to actually achieve that task. But if I gave you a deck of cards in a group, so let's say I gave a group of 10 people one single deck of cards, and I said, sort, do the same thing, it will take them significantly less time than it will if I gave just one person a deck of cards to actually achieve that end result. So that's the idea of MapReduce. So we partition our information out into very small parts. Then each of those small parts has the same task done to it. And once that task has been executed on the small parts, all of the end results are then combined to produce the final result. So let's take a look at another example here with word count, which is a real classic example of how MapReduce works. So our input here is a very simple section of text. So a bunch of different words: deer, bear, river, car, river, deer, car, bear. So you can imagine this being a very large book or something like that, and we want to count the occurrences of each word in our data set. So first thing that we do here, let's split this data out. So let's say that each line of text here is our initial split. So deer, bear, river, car, river, and deer, car, bear. So we have these three data sets that are our big data set has been split into these individual data sets, where the key value, we have key value pair where the key is this as a document, the value is the text that we actually contain. So each of these documents here are then going to be mapped to a task, and our task here is to count the word occurrences. So in this mapping task, I'm going to map each word to a number. So each word, of course, and individualized, is only going to occur once. So deer occurs once, bear occurs once, and river occurs once. The key here is going to be word, and the value here is going to be, of course, the word count. Now you can see down here in this middle example where we have 2 cars. That's okay, because it's individual tasks, remember? So each car is still going to be one key value pair here, because the important part actually comes in the next step, or in the next few steps here. So we're actually going to shuffle this out. The shuffling process is going to take care of essentially sorting the result of our mapping process. Because once it's actually sorted, it's a lot easier to actually reduce and combine. So when we actually shuffle, all of the bears get put in one bin, all the cars get put in one bin, all the deer get put in one bin, and all of the rivers get put in one bin. And then all that happens here is actually the reducing. So we're actually combining one more step to actually combining the information. So we sum the word counts. So bear occurred twice, car occurred 3, deer 2, and river 2. So we've taken all of the individual words here, counted them, sorted them out, summed them, and then the final reduce phase is we've combined this all back into a single list where the key is the word and the value is the total word count over the entire data set. But you can imagine this to be significantly faster than having one single process or one single computer doing this. We can use this on things like Beocat, a distributed computer system where we can split the data set up and onto a lot of different processors and have each processor or each thread actually execute the mapping, shuffling, and reducing task. And then they all come in back together at the end to form the final results. But this is just one of the big data algorithms out there. There's obviously a significant amount of other types of techniques and algorithms and tasks out there that big data can actually accomplish. So we just scratched the surface here. But if you're interested in learning more, please reach out and we'll be happy to actually connect you with more resources.